the flyer, which we shared beforehand, the topic was innovation in IT security with BlueSpice and Secure Wiki to meet the latest security requirements to secure wikis by Secure Wiki services. So we use cryptography, as already was said, to prove authenticity and trustworthiness of your wiki stored data. And just a little bit of background, I will just skip this slide because this was already said. I work in IT since 2010 in IT security and in distributed systems and open source in different international projects and also with the public sector in Germany in the past. So why this combination of Hallo Welt and Blockio is so good is because of open source, obviously. Our mission statement is that we believe in digital sovereignty, so that you have the right to manage your own data and to own your own data for self-directed, sustainable, and trusted value creation, because obviously it's a huge market and we want not a couple huge companies, but we want that like also small players can participate. And we achieve this by developing open and resilient services to enhance trust. So when we introduce Aqua, we introduce it as a technology in the form of a wiki extension to establish secure wikis for reliable knowledge and data management. And this extension can be seamlessly integrated into BlueSpice or any other MediaWiki deployment. And I'm really glad that we came together, and it's only, like I said before, it's only possible because of open source technologies. So a little bit to the background, the development of Aqua began in 2021 as a free and open source, more research project from Blockio. And then we had the chance to work with a larger player in the public sector to develop it further to a prototype for digital verification of educational certificates. Which was for the education platform, open source platform of the Bund. And we got it ready for this project through the help of Hallo Welt with their expertise for enterprise wiki integration. The project was completed originally like Q1 2022 with a prototype ready to go. And we picked it up again in Q1 2023 after a break in collaboration with Hallo Welt, bringing it here to you today. So what are we actually doing with Secure Wiki services? So we separated in 3 services. They all work more or less independent of each other. So the first thing which is important for today is the question of like, how do we sign or sign in? So how can we use digital signatures? And to use digital signatures, we need to have something to sign with, like a private key. And we use something which is called wallets. I will introduce it in a bit, but it allows amazing things like passwordless login and also signing documents. Furthermore, it's really important that we safeguard the integrity of data so that it's impossible that you can manipulate data sets in your wiki. And the third area which we will look into is cryptographic timestamping, or a different way of saying that, to prove that something existed at a certain time. And together, those services can allow for e-notary services, a new method to do contract and access management, which is, from my perspective, super exciting. Let's dive first into the e-signature service. So it allows for passwordless login. As we will look into it. We will have a couple of live demonstrations during the sessions, and it allows for digital signing a document to secure a page with a signature. So I have seen, for example, this page in this state. You are able to combine it with things like BlueSpice workflows to sign off of documents in certain stages. So it's an accountability, a way to keep things accountable. And the benefit of this is we do this all open source on the Wiki server or in a secure Wiki container, which you can deploy also locally. So your documents never leave the organization, which means like you're not sending it to a service where it's signed. No, you're signing it inside your own domain. So we use an extension, a browser extension, to even allow you then to export, for example, a Wiki article, and somebody else who doesn't have the secure Wiki service can then just use a web application like a Chrome extension to then use it to verify the data set. So because wallets is something new for many people, let me give a short introduction into why wallets and why we do it, why we do it. Wallets are usually known, like broadly known from the crypto space to trade crypto assets, so like Bitcoin or Ether or something like that. We only use it for the key management purpose. So those applications are actually not interacting with any service when we are signing into our containers. They are just interacting with the service we have locally, or if it's on a web server, we have it there. So MetaMask acts just as the key management system. And with that, we have a user key, which is the public key, which we can use then to sign into a service. And this service is, for example, our secure wiki. Or we could say it's a data vault, because we could, in theory, encrypt it as well, which is the service. So we separate the user management from the service. So in case the service gets compromised, there is no user data actually there. If you don't store that, we don't need that for secure login. So the wallet is really the thing which keeps your private key safe and which gives you a public address to that private key, so that you can make statements about things. Like, for example, this is my public address, I signed something with it, and the cryptography can then check, was it really signed with that private secret the user holds. So we use it for signing, decrypting, encrypting, and publishing transactions if we want to. We use one service which can publish to a blockchain, to Ethereum, for witnessing, so for publishing a cryptographic proof of existence. And on the other side, the secure wiki is not bothered with like how we do the key management. It just does the data management. So for example, the backup recovery. And if we extend that with the Guardian, we have like access control. And we can obviously keep confidential instances if we secure them in addition, like keeping them in separate secure networks. So the benefit of open source is that we haven't developed MetaMask. We use it. And it's a software which is used by over 10 million users, which has been battle proven. And if you're like, I don't want to keep my keys in the browser, that's fine as well, because there is an option to use consumer hardware, which is actually quite military grade. So this is a ledger, which you also see in the picture, which is a hardware token. You can buy those for like $50. And what you get is a manipulation resistant, like external storage for your private key. It's like similar to YubiKey or to a two-factor like card you could have with like your mobile phone and an NFC chip. So this EIL5 certification means that when somebody tries to steal your private key from that security token, that this is hardened against that kind of extraction. So we get that infrastructure quite for free because it was developed for the crypto space, but we use it for keeping our keys safe. So you see here, this is the Ledger 2, and you see this CCEIL5 plus certification, which means like it's hardened against key extraction. If you have the situation that your computer is compromised, you will not lose your private keys. And that's a huge benefit, obviously. So let's look into how this actually looks like in the real world. So we will have a short demo of passwordless login with a wallet. I will use the MetaMask wallet. And we will, instead of using password and a username, just assign a message with our private key to log in. Just keep in mind, you say, why is he introducing a new user management? Well, you might have an LDAP user management for your Windows users. You can actually extend those users with an attribute, which is the public key. And then you can use an authentication service which authenticates against OpenID Connect against the LDAP. With a signature challenge. So you can actually extend your existing infrastructure with adding that ability if you want to. The MetaMask web extension we will look into. And then I will show you how we log into two services. One is the secure messenger, just to show you that it's like OpenID Connect. It works pretty much for every service. And we have just adapted it for Wiki as well. So we are going to sign in to Wiki as well. So this is the MetaMask web extension. You can easily install it just by going to the web store and installing it. And like I said, we benefit from all the other users and the huge development base behind it. And we are going to log in into a secure messenger here. In this case, it's Matrix. And we are using a private instance, which we have modified to allow for this signature challenge. And what we are doing is, this is the demo bots. When the demo, when you make the demo, it doesn't work, and when you tested it 20 times before, it was always working. So we will give it one more shot, and if not, we just skip that step. Let's see if the demo gods are happy with us now. Yeah, now it works. So you see that I have the ability to connect with OpenID Connect here, which I'm going to do. And what it's now doing, it sends me to the authentication challenge from eAuth, which is a wallet signature challenge against my Ethereum wallet, which you see in the upper right corner with MetaMask. So I'm going to do Ethereum login. What it does, it triggers the wallet to activate. And I was already logged in. Usually you need to type a password, and then you see authentication with your Ethereum wallet, and I'm going to sign it. So what I get is now a signed key, and I can click authorize, and then it forwards me to my service. And you see my name is Fantastic Mr. Fox, but actually the ID I have is the public wallet address. So this is the address which is here in this wallet, which I can copy and just paste to show you it's the same. Okay, so this was signed in Matrix. What we are going to do now is you see pkc.inblock.io. I started a test instance you can use after the presentation if you wanted to play around with it. I have created open user registration. So there's an explanation how you can create your own user account on this instance, and it will be online until Friday. So feel free to play around with it. And here I'm going to sign in with eAuth. Again, you have seen it before with my MetaMask wallet. So we sign in, and if everything went well, we see our address on the upper right corner. And now you might say, well, why do I want to have a username which looks that strange, right? So that was the same for us. So that's the reason why we have a local name resolution. I will go to the user page. This is my local user page. Nothing exists there right now. But what I will do first is I will just make a statement about this user and sign this page. So you see how signing looks like. I say, okay, it's Tim. And I say, this is my address pretty much with saving it. I'm proving it because that's my public address, right? And the only person who can prove that it's like mine is when I do a signature on it. So what I'm doing is I sign it with my private key now. And it looks very similar to what you have seen before with the login. It asks the wallet, and then I sign a message with my wallet, and this data is pushed back to the wiki. And now you see that there is a signature added. There are two parts of that. One part is what the user sees in the wiki, and the other part is what the user sees with the external verification process. So the external verification process is this web application, which is called Verify Page. And in that web application, every revision is verified. And here you see, for example, the signature symbol, which means like there is a cryptographic signature which got checked. And you see that there is a valid signature from this wallet. If I click it, I end up back at the user page. Now, I don't want to have always this long hash. That's the reason why we introduce a local name system resolution for those hashes. So I can click resolve name. And I said, I add a new entry for this username. And obviously, this is something which we can automate also in a federated system so that we have a distributed name system for those addresses. We could also integrate with Ethereum name system if you have heard about it. So there are various ways how we can turn those long addresses into names with various levels of, say, assurance that it's really the person which is claiming it to be, right? And now you see also in the signature, it's 10. This is it for the signatures. Let's come back to the presentation. So we have seen what MetaMask is used for. We have seen a sneak peek like in our external web extension, which we will speak more about. And we have seen that you can do passwordless login with open source infrastructure, which doesn't need to communicate with any other service than its service it's connected to. Now we have also seen the basic address name resolution. and we have signed a message. Let's continue. And I want to show you in this very short clip that it's possible to use those external hardware wallets to sign in the same way, or to sign a message in the same way as you have seen before. You find this video also narrated in our YouTube channel, so you can go there if you want to see it again. You see that there is a software which manages those hardware wallets, and this is the Ledger Live software. And in this Ledger Live software, we need to say you are allowed to speak to the web application. And what you get here is the recording on the button, which now asks for the signature challenge, where you see the signature challenge, and then you can confirm the signature challenge, which gives you the ability to use your external hardware wallet to sign through directly through to the web application to log in. So obviously, some people want to use other systems, like maybe you want to use a YubiKey, maybe you want to sign in from a command line, maybe you want to use your digital identity as a way to sign documents or to sign in. This is absolutely possible with the data structure we have built. It's not integrated at the moment, but we would love to do that integration if we have a customer which is asking for it. So it's a powerful possibility to extend to different signing methods, which acts similar to what you have seen with the wallets. Let's speak about the second service, which is the integrity verification. So why do we need integrity verification? Obviously, we want to ensure that we don't have, for example, a hacker changing a document, right? Or we don't want to have the situation that we have a malicious employee which alters a record, or we just have a system error corrupting the data. No matter why the integrity of the document was infringed, we want to actually have a way that we can be sure it wasn't. So the integrity verification shows and ensures that we can trust all the revisions have not been altered, so that they are correct. And we do that by creating hash chains. So every revision has a hash, a revision hash, and this is included in the next revision. We also provide immutable links, which means we can ensure that we can link to another article. And then when we link to another article, it's like we link to a specific revision, but with a hash. So we can also check if this is really the resource which was linked in the document. So scenarios are various. One could be an audit trail. Another one could be integrity check after backup and recovery. Another one could be cloud integrity. You name it. Tracking a contract. There are various like reasons and scenarios why you might want to do that. There are two ways to generally do it. One you have already seen. This is user-driven through the web application, through an API, which is requesting all the data, and then rerun all the cryptographic verification steps to ensure that the data integrity is given. The other one is that you do an automated background check with the Guardian, which is then crawling all the data from the Wiki instance, checking it, and sending back a log with the confirmation that everything is fine, or if something is not fine, as well, that it was manipulated. And the log itself is also a cryptographic secured piece of data. So for the verify page extension, you just install it like the MetaMask extension. You just search for verify page. And what you get is then the verifier for all the different cryptographic activities we do. So what we see here is Alice on the right side. She wants to like communicate with Bob, and there might be a situation that Alice and Bob have created a contract, and Eve, the evil monsters, now want to attack this contract and change it. So what we will see in the next demo is like how you can change a contract, or how you can try to change a contract, how a failed signature looks like, how a failed integrity check looks like. And we see the import-export procedure, we see immutable links in action, and we see an offline verification. Let's jump right into it. So what we want for this is the very important contract. So what you see here is a contract which has two cryptographic signatures from Alice and Bob. Bob says, when I die, I give all my belongings and assets to Alice. And Eve thinks, well, I want to change that name. It should be me who gets everything, right? So we do an export of the data set. We include it depth one, which means like it exports all the other pages which link to it in depth one, which means like the user statements of Alice and Bob as well. And then we go to open this contract in the console. I'm now the evil hacker. And I'm going to change the address from Alice to Eve's, right? So to do that, I need to copy over the address, but also I need to find it in the code. So we have, okay, here we have user Bob, here we have user Alice. The key, you see it's not translated to the name, but the name resolution is on another level. So I will delete this very entry, and I will replace it with Eve's entry and save it. So now we have the manipulated data. I have it here in my Explorer here, and now we are going to verify it in the offline verifier. So if you don't have the secure wiki infrastructure, but you want to verify a document, you can do that with the offline verifier, which is part of the web extension. And there you just pull the document in which you want to verify. And now you see, okay, we have different documents. You see the identity, so the user pages from this is Bob, this is Alice with their signatures. They have not been altered, but you see that the revision 3 of this current document was altered, and that's the reason why we get a content hash doesn't match, right? So you know that the data which is in this page, you cannot trust it. And this is what is important. If you get a red flag, it doesn't really matter why, as long as it's not a bug, you can't trust that data set anymore. So for the purpose of you seeing some other error messages, I want to show you how invalid signature looks like. So I have prepared a file where I messed with the signature, and you see this looks like this. Also, page integrity verification failed. And I want to jump a little bit forward to show you the error message for how the cryptographic timestamping can fail and how it looks like when this fails. This says the witness Merkle proof was corrupted, which means like the proof that this document was part of the cryptographic timestamping was broken. There are some other error modes, but this is just that you have seen, okay, red page, it's not what you want to trust. So that's all nice, but a contract should be able to be exported and imported, right? So what I'm going to do is like, I will import that document into a different secure wiki. So you see it for the administrators in the ranks, you will see I'm at localhost. This is not the same website anymore. I'm on a local deployment on my laptop. And on that local deployment, I'm going to like import the contract. So I'm going to sign in with my wallet on my local laptop. And with that, I'm able to click the import verified page option. And I'm going to import not the manipulated version, but actually the original version of the very important contract. So I go to my downloads, to the demo data, and I have here the very important contract and import it. And now you see I have 3 pages here, the very important contract. And we see now the verifier runs again, verifies everything is fine. That's great. I have the signatures and I have the included resources, which are those sub-pages for the users. So just to show you a little bit different scenario, I will import a second file, which is a file about a report claim about fake news. And this is it. It's that's the report. Let's fire it up. It's a report about a fake news article I have generated with some AI tools yesterday. It's about the famous whistleblower Andrew Stenson, who got arrested at Dallas airport. The picture is also from Midway, manipulated. And we have Bob, who says, well, actually, I account that this piece of information is wrong, and I signed this document to state that it's wrong. So I see, okay, Bob has signed it. I can click it. Bob's claim that he is Bob is also here, which is a self-signed identity claim. But obviously, this could also be a photo of his ID or whatever. So if I go back, there is a PDF which is in here. So I can also open that file, which is inside this document. And we have also integrity verification for files. So you see here the integrity of the file was checked. This is really important because this gives us the ability to keep track of all the assets which we want to put into the wiki and which we want to secure. What happens if I delete now this news PDF? Let's do that and go back to the report. Yeah, you know how it looks like when there's a resource broken, but there is something more which is notable, which is that we now see there is an invalid hash or verification data is missing. So this means it shows me the reference where it's pointing to doesn't exist or has been altered. If you now upload the same file again, which isn't exactly the same file, it will detect it and it will say invalid hash. So these are amazing properties to ensure that our data structure, our knowledge management is correct. So let's jump back into the presentation, because what we have seen is all what I wanted to show at that point. We have seen that we can check the integrity of an article. Now you can see it. The integrity of an article. That we can see how failed signatures and failed integrity looks like. That we can import and export those verified data structures between secure wikis. We have seen how the immutable link works in action, and we have seen the offline verification, which gives you the ability to export contracts and send them over to somebody to have them check it. By the way, I didn't show that, but you can extract PDFs out of the data structure again, also with the offline verifier. Let's come to the last service, the digital cryptographic timestamping. And with it, it's pretty straightforward. We can combine those services, the integrity verification, the signatures, and the timestamping to create e-notary services, which can run totally autonomous on your local machine. Just for the timestamping, they need to be able to reach a witness network, in this case, Ethereum. But for everything else, it's all happening on your machine, and you get the cryptographic proofs. So why do we need it? If we want to prove to a third party that the document hasn't altered, so if we need a proof of existence, then the cryptographic timestamping comes in handy. It is a way to cryptographically prove that we have like a tamper-proof method for validating document authenticity and providing an additional layer of trust and credibility. And the timestamping can help to resolve disputes by providing irrefutable evidence of the documents in existence. So this means especially if we want to use them to manage access rights with contracts, payments, invoices, there's always this time component that we need to ensure this is really from that time, because access right is usually also given for a period of time. So the benefits of the timestamped and verified signed documents is that we can enable machine and human readable contracts, where, as a summary, the signature ensures for accountability, the integrity verification ensures for authenticity, and the timestamping provides a clear and unaltered timeline. With the combination of all of this, we can really change the way how we manage documents and how we account for documents. We showed that we can import and export them with the cryptographic metadata, and that we support a wide range of different file types. And we can even like upload videos, or you have seen photos, and you will see more of that. So the secure wiki services in combination with the Guardian is a perfect solution for legally compliant data management. So you can use BlueSpice with secure wiki services to separate data, which should be confidential, in a separate wiki instance, like on a local machine or in a protected machine. And you can track your contracts, for example, with the revision-based like changes which are stored, and with the signatures, you can keep them accountable at all times. And with that, we can facilitate a secure digital contract management. So this is going to be my last demo for today. It's like the demo for the digital timestamping. So we are going to see how it looks like to generate digital timestamps and to send them to the Ethereum network for witnessing. And we're also going to look like how it looks in the verifier. So I'm going back to the public instance of the pkc.inblog.io, and I'm using the data accounting extension to generate the domain snapshot generator. So the domain snapshot generator is taking all the different verification hashes of all the documents in the container. You see that. So all the pictures, by the way, you see are AI generated, actually 90% of them. Even pictures like this, which is like unrest in Berlin. It's crazy what's possible those days. Even more important that we can keep track if data was altered or not. It's also a way that you can obviously prove that you have seen something, right? Because everybody can make up a tweet or delete it again. Or you can use it for your contracts, for your employee contracts or whatever, right? So all those contracts, all this data, and by the way, even this picture is AI generated. It's like a little bit frightening, but this is crazy what's possible today with the forgery of images or data sets fully automatic, right? So all those documents are put together into a binary tree. And the binary tree, the left and the right leaves, are the hashes, like the digital fingerprints of that digital object which we want to protect. And this is put together to one single fingerprint. And this is what's going to be sent to a witness network. So what we are sending here is not any data from the container. What we are sending is the fingerprint, which summarizes all fingerprints. So there's actually no information about which data you hold in that container when I'm publishing here. So I'm going to say, look up, and we will look how the transaction looks at the blockchain. So this is the transaction which is sent. You see it's pending. Now it's indexing, which means it has already been written. We are waiting for a successful booking. So this means that the transaction was successfully booked into the blockchain. And now we will look how this transaction, after it was successfully booked into the blockchain, actually looks like. So what was the piece of data which we have sent, which is so powerful that it can prove the existence of all the other objects in our secure wiki. And this is it. Like here in the payload, you see that it's just this string. It's the SHA-3512 hash. It's 64 bytes of data. And this gives us the ability to construct a proof which is stored at every hash chain itself in every article, which now can be used to verify a data set. So if I go back in here in the domain snapshot, and I, for example, take this picture. Let me take a page because I can directly navigate here to it. So for example, Alice's page, you see in the verifier that there is this clock symbol. This clock symbol is the cryptographic timestamping, which checks with the Merkle proof if this was really indeed part of that publishing event. So what we have seen is how cryptographic timestamping works, how we generate the snapshot, how it's published to the Ethereum network, and how it looks in the verification application. The question is, how does the road ahead look like? Well, I think it's a bright road. I think I see a lot of opportunities here for creating a peer-to-peer secure wiki landscape where we can exchange data between secure wikis, where we can subscribe to articles in remote wikis, because we have the possibility to create a strong access permission management with the signatures and digital contracts, which are enforced by the guardians. So we plan to expand the piloting activities to also include this. This is currently not developed, but if we have customers which support us with the pilot process, we will be able to move forward in this direction. And this is a very, very nice side aspect that we solve the the peer-to-peer wiki ability with changing the address schema of all the articles. So this is the call for action. We need to pilot the software. If you have interest in piloting the software with Hallo Welt and in Blogio, please reach out. And if you want to learn more about it, there is a link to the Hallo Welt website, and there is a link to the community page for the Aqua protocol, because as said, this is one possible implementation. There are other ways to implement this. And there is a test instance which I will keep running until Friday on pksc.inblog.io. On the main page, there's a clear explanation how you can create an account. If you need any assistance, feel free to reach out.
What's exciting about this is this is a bit like Cloud Dogo. We don't talk about theoretical things, something that's only lives in PowerPoint. So what we see, it's already running. Of course, there's always something to do to improve, but it makes a huge difference to see how this works and how this behaves. And I think that project opens a way to new applications based on MediaWiki. So MediaWiki is the basis, like where your information lives, where the knowledge is, and that can now be verified. But you can do much more than just having some sort of a knowledge base. You can have verified knowledge bases, but as you said, contracts, any sort of verification, signature. This is really, really, really great. And yeah, I sometimes think there's also a need for, if you have an automated or a semi-automated documentation, where you collect information at a certain place, somebody is checking it, and a human being or some human being say, this is exactly what it is about.
Actually, we can also do it with machines, right? Because we are speaking about accounts. There is no reason why we can't give a private public key to a machine, right? And we can have a sensor signing off on specific data sets. That's no problem. So it's really like it's equally for humans or machines to create and process this data. That's really like it can solve a lot of problems we have today. I think that the need for such software will only increase, and I'm glad that we have it ready for piloting. So whenever somebody comes around who says, "Yeah, I want to try this based on a purely open source basis without like third-party server dependencies," we are ready for it.
Right, and you already mentioned the news are full of reports about artificial intelligence and how data can be manipulated. And I think that's a huge question in this decade. And so I can't wait if that technology could be one answer to tackle this.